Agile was supposed to be a revolution, but somehow it lost its way because we lost the one thing that made it work, the technical heart. We kept the stand-ups and the sticky notes, but we forgot how to write great software. In this video, I'll show you what Agile forgot and how AI just might be able to help us rediscover it. So let's dive in. Agile was built on technical practices. The Agile Manifesto was written by a bunch of software developers. All of the original authors of the Agile Manifesto wrote code, and they wanted to help people write better code. I know that the first line of the Agile Manifesto says people over process, but we have to look a little bit further than just reading the first line. All of the 12 principles are really about software development. It was about how to build software in a way that makes more sense, that's more in alignment with the nature of software rather than the nature of physical construction. I think one of the main things that made Agile work for software development was extreme programming. It was right around that time that the Chrysler project happened, and Kent Beck and Ron Jeffries and a bunch of other people got together and found that building software in short iterations with lots of feedback, with automated tests, integrating as you build, all of those things were incredibly successful. That, to me, is the heart of Agile, because Agile is all about software development. That's where it came from. Most teams wind up adapting and adopting processes, but not practices. And because of that, they kind of go through the motions, but aren't able to be highly effective. The software that I see a lot of teams build is a kind of one and done thing. Like, okay, I'm going to build this feature and then I'm not going to look at it again. But Agile really works best if we build our features incrementally. Start in the first sprint with the basic parts of the feature. And then in the next sprint, handle, other aspects of it. That only works really well if the code is kept clean and we can easily go back into it. If we make a mess and we don't know what's going on, then we spend all of our time thrashing. And I see a lot of teams end up doing that. That's not the essence of Agile. It's like having a high-performance car with no engine. It looks good, but it doesn't take you anywhere. It's the technical practices in Agile software development that take you places, that give you the flexibility to truly be Agile, to be able to respond to change. So what are those kinds of things? From a technical perspective, it's understanding the separation of concerns between what we want to build and how it's being implemented. That gives us the freedom, when we can separate those two things out, to be able to change our implementations in the future without breaking a bunch of stuff. I think that, technical practices can be intimidating for people. I meet a lot of people, managers, who are kind of scared of some of the technical practices, but honestly, they all boil down to common sense. Test-driven development is just creating some validation, understanding what it is that we want to build before we actually build it. And we do that all the time with building physical things. And so embodying what we want to create through an assertion, through writing a test, is an incredibly powerful way of seeing that piece that we're building as autonomous. And we want to do that because when we can do that, we can build it into the system, and when it needs to change, it doesn't break a bunch of other things. Why did the technical practices disappear? Because business is not focused on it. It's not focused on quality. They're focused on visibility, And Scrum became mainstream because it basically promised that if you just follow these processes and do these meetings, that your software development will work out. And it really does look really good in the beginning. This is the trap of a lot of the Agile software development processes, is that it looks like you're making great progress. But after several years, 5 years, 7 years, you're not going to find many projects that are still alive in that time that are using Scrum or SAFe, because the technical debt that is accumulated eats the system alive. I do know teams, the top teams, that are really using this extreme programming practices to their benefit. They're doing test first development correctly. They're not just using it as overhead and doing it wrong, which is far worse than not doing it at all. You know, having a bunch of tests that break when you go to refactor your code is very disheartening. It terrifies people and it backs people off from wanting to ever touch any code at all again. So we don't want to write tests that pin down those kinds of behaviors in that prevent us from refactoring code. We want to write tests that support us in refactoring code. You know, they say the same medicine that can kill you can cure you. And it's true with these advanced practices. You can use these advanced practices wrong and completely mess up your code base. Or you can do it well and you can thrive with it. It depends upon how you apply it. So again, it's all boiling down to common sense. So what's the common sense around this? Well, we want to be able to refactor our code safely in the future. Sound good? Yeah, right? We want to be able to change our code's implementation in the future without breaking the behavior. Why do we want to do this? So that we can accommodate new features typically, you know, because software is constantly changing and growing and we want to be able to change and grow with it. You're probably facing a very challenging code base if you're like 99% of the companies out there. And so you're probably spending most of your time putting out fires. So the first thing to do is stop the bleeding, you know, get yourself into a stable position by writing good code or by trying to at least patch things up. And when you get time, that's when you can start to refactor and clean up just the modules that need to change. If it ain't broke, don't fix it. I taught refactoring to a team that had never really seen clean code before, and they floundered for a long time. But once they started to really understand the principles behind clean code, like single responsibility, and started to create a good domain model, it really changed their perspective. And I saw them really growing and learning, and the code base changed significantly. I came back to a year later, and they were thriving. And it was because they understood how the principles of software development and writing good code related to the technical practices. I think that's where the disconnect is for most people is they go through the motions, they do the practices, but they don't see a lot of progress because they're not aiming the practices towards building a strong domain model, creating a reflection in the code of whatever it is that they're modeling. AI can help us bring back the good technical practices. They can help us recover what we lost. AI thrives on having good patterns, having models that it can work from, and good structures. It's really good at writing tests and suggesting refactorings. So if we make good code a priority and we teach AI how to build it and we give it the space to do it, then I think it could be very powerful. The irony is that AI wants what Agile forgot. It wants discipline. It wants structure and feedback. I asked AI to refactor a God object, and it completely understood, but only after I gave it the model to be able to refactor to. If your team is struggling with bugs, technical debt, and vague test coverage, AI can help, but only if you know how to use it well. The AI Coder Cheat Sheet gives developers 10 practical ways to use AI right now, to write cleaner code, generate missing tests, and solve real problems faster. It's like giving every developer a senior AI pair programmer. Would you like a copy? You can download it free as part of my AI for Agile Toolkit. The link is in the description. I've spent enormous amounts of time working with ChatGPT and other large language models. And the very best advice I can encapsulate in just one simple statement: treat it like a human, treat it like another person, treat it like a junior developer. Because when you do that, it creates the space for it to come back and provide ideas and provide suggestions. And, they actually turn out to be kind of useful, kind of interesting, many of them. So create the space to let that happen, and then the AI will do that. Agile can be reborn, but only through technical mastery. And that mastery has to come, if we're going to do it with AI, from both sides, from the human side and from the machine side. It's like bringing jazz back into musical education, where it was all about rote memorization for years. We need to be able to riff and improvise and think creatively again. I think it's going to open up a golden age in software development, and I'm excited about it. I hope you are too. And I hope you stay tuned for more, because I got more coming. So please subscribe. I introduced TDD to one team and their productivity doubled within the first month. Now AI can automate more of what they're doing. A lot of the technical practices that we've been talking about for years mesh really, really well with bringing AI onto our teams. A lot of the XP teams and mobs that I've seen were able to immediately bring on AI as a team member and get lots and lots of benefits. This is now for years, which is great. So what does all of this mean for the future of Agile and AI? I think Agile didn't fail because it was wrong. It failed because we forgot its core, the practices that really made it work. And now AI is just bringing these practices back, but only if we know how to use the technical practices to build resilient Agile software. In our next video, we're going to explore how software design can emerge incrementally and how AI can help us grow systems, not just generate scripts. I'll see you there. Happy coding.